Okay, here we go. 1.6b, pre-calc composition of functions. So second section of 1.6 notes, and we're basically gonna talk about when we kind of have a function and then using that function to evaluate a second function. So kind of like a function within a function. As we're talking everything functions here in chapter 1. All right, so here's the general idea here. The composition of a function is right here. A function f with function g is this, written as f of g of x. That's how we would say it, okay? F of g of x. And so basically what we're trying to do here is this means that the domain includes all of x values in G that map to the ones that, like we show on the diagram here to the right. If that's not clear to you, basically it's a function within a function, and kind of just write this down here. You kind of work inside out, from the inside function going out. So we would evaluate G of x first, and then plug G of x into f of x. So let's do some examples with that, because it's just kind of easier to work through these. Okay, so first thing again, as we talk about, is that f of g of x, remember, is kind of written like this. We're going to take f, and then we're going to evaluate g of x into that f function. Okay, so first, what we're going to say is that g of x is x minus 4. So really, we're taking f of the g of x, which is f of x minus 4. So now we're kind of plugging that x minus 4 into, we're taking this and plugging it in to the f function. So now we're basically saying x minus 4 squared plus 1, because we're plugging it into the f function. And then as we do that, x minus 4 squared comes out to x squared minus 8x plus 16. And then we have the plus 1 there. So we combine like terms here and here, and basically we get x squared minus 8x plus 17. Okay, good. All right, so let's do another one. Okay, so let's do g of f of x. So kind of this is the reverse now, right? This is going to be the reverse action. So now we're basically saying that this is the g function of f of x. So we're basically going to take the f function and plug it in here. Is going to get plugged into this one now. Okay. So when we do that, we can see that g of f of x, if remember, so we're taking g of x squared plus 1 now. So we're plugging that into the g function. And so if we continue working, basically you're going to get this x squared plus 1. We're plugging that in to this x right here, and then we have that minus 4 of the g function. Okay, and really we can again just kind of combine like terms here, and so you're going to end up with x squared minus 3 plus 1 and minus 4 make minus 3, and that's that. Okay, so far not so bad, right? Now, f of g of 2. Now, if we're actually evaluating an actual number, so g of 2. So this is going to be written like this. Okay, so we would write this f of g of 2. So we're going to evaluate the g function with 2, and then we're going to plug that into the f function. Okay, so if we remember that the g function up here, so we're saying f of, okay, we're going to evaluate the g function. The g function is x minus 4. So if we evaluate that, we're saying that it's basically f of, and I'm just going to use parentheses here, 2 minus 4. Okay. So really, when we plug it in the f, it's going to be f of negative 2. Okay, and then we can plug that in to our f function, so it'll be negative 2 squared plus 1. And that's going to be 4 plus 1, which equals 5. Okay, so we just evaluated it in G first, up here, right? -2 minus 4, and then we plug that result in here into the f function. Okay, there is another way to do that since you already did the previous work and say, well, we already know that f of g of x right here, we did that and was right up here. Let's use blue here. Okay, because we already know we did this already, f of g of x. So all we're really doing is kind of plugging in a 2 there. So I've already done that work right here. This is f of g of x. So I could have actually just taken that down and done that x squared minus 8x plus 17, and then plugged a -2 in for x. -2 squared minus 8 times -2 plus 17. Regardless, you end up getting, what, 4 minus 16 plus 17. So you still end up getting the answer of 5. Either way you do it. Either way. So if it happens like in your assignment where you've already got the answer, we already did the pre-work, you can kind of speed through it a little bit more. Either way, it's the same thing. Okay? So that's a composition of function. What happens if, the next part is, what if we have a restricted domain, right? So sometimes we know that there's a restricted domain when the denominator, or when we have a variable in the denominator, because we don't want 0, so it can't equal 0, or under a radical sign. Remember, so radical sign can't be negative. So what happens then? So we might have to have some stipulations on that. Okay, so if we kind of evaluate here, f of g of x when f of x is 1 over x plus 1, and g of x is x squared minus 9. So again, if we're going through this, we're going to look at it and say, all right, well, I know that this is f of g of x is going to equal f of, so we're doing this, f of g of x. That's going to be f of x squared minus 9, because that's my g function here. Okay, so if I plug that in for my x right here, basically I'm going to get, it's going to equal 1 over x squared minus 9 plus 1, which equals 1 over x squared minus 8. Okay, so what we know here is that this is what it would look like. However, we just can't get a 0 in the denominator, right? We can't have the 0 in the denominator here. So what would make that 0? Well, if this area here is equal to 0. So I can just kind of write that down. I can say, all right, if I put, if I say that, set that denominator equal to 0, x squared minus 8 equals 0, I'll find what will make it 0. So I add 8 to both sides, I get x squared equals 8, square root both sides, so x equals the square root of 8. And we can kind of go ahead and break that down further, right? It's be plus or minus 2 times the square root of 2. So that's what it can't equal, because that would make it 0. So how we would write this would basically be 1 over x squared minus 8 for x not equal to plus or minus 2 times the square root of 2. Not equal to. Okay, that would kind of be your final answer, because we have to have that restricted domain. We can't have x be equal to plus or minus 2 times the square root of 2, because that would give us 0 in the denominator. Okay, all right, so let's do another one with radical. Right, so again, we're trying to find f of g of x here. Okay, so when we do this one, we're looking at f of g of x. So really, it's going to be f of the g function, which is the square root of x minus 3. And then we plug that into the function and we go. So we're looking at This one being where was I? Oh, here we're plugging this whole thing into this x squared. So now we're saying that it's going to be the square root of x minus 3 squared minus 2. Okay. Well, we know that that squaring is going to undo that, right? So let's kind of move it up here. Right? We know that it's going to be, when we square a square root, it kind of undoes it. So we've got x minus 3 minus 2, which equals x minus 5. Okay, so that's a tricky one because at first we look and say, yeah, that's good. We've got all reals. Everything works for x. However, it won't work as you're working through the problem if we have a problem here. So we could say that if x is less than or less than 3, really, it's going to give us a negative square root, and we can't have a negative radical, right? That was one of our rules here. Can't have a negative under the radical sign. So when we look at these, we can say, all right, 3 minus 3 would be 0. That would work. But anything less than 3 would give us a negative number. So I can say x equals x minus 5 for x being greater than or equal to 3. Because anything else, if greater than or equal to 3 will work, we're positive or 0. So we have to put that stipulation on there because there's a radical. So anytime there's a variable in the denominator, we got to think can't have it 0, so we have a condition here. Or anytime there's a radical, can't have a negative under the radical, so it has to be a condition there. So just kind of have alarm bells in your head about that. All right, decomposition of a function. So we composed functions within a function. Here we're going to kind of decompose them. We're going to take them apart, a function, and kind of split them up into a composition. So what we're kind of doing here is we're simplifying a function into two simpler functions. So to do that, we're going to find two functions with a composition of h, where neither one can be the identity function of the x equals x. Basically saying you can't just say one of them is 1 times the original function. That doesn't count, okay? So some examples, some ideas that will help you as you go through it here will be that in some cases, if it's a polynomial, you're going to have to factor, and that'll help you to decompose the fractions or the functions. If it's a radical function, so we've got a square root sign in there, or a reciprocal function that's got a fraction, right? Then one of these will be the parent function. Okay, one of these will be the parent function. Notice it's different, not the identity function. That's different from the identity function. The parent function can work, right? So that kind of helps us as we go here. So it's kind of think of it as like factoring and decomposing this into two separate functions that turn out to be composed one another. All right, so let's do some of these practices. So number 3, when we look at it, number 3 is we've got a radical. We've got x cubed minus 4. So if we want to kind of separate these, we've got our functions here says find two functions f and g such that when we compose them, we got f of g of x. So neither can be the identity function. Can't be this. Basically saying I can't just multiply 1 by this here, okay? So what I want to do is kind of decompose this. So one of them will be the parent function. It's different than the identity function. So if we just say, take the stuff underneath the radical here and say g of x equals that, x cubed minus 4. And then if we say f of x is the other thing. What's happening to x cubed minus 4? Well, it's being the square root. So if we just say f of x equal to the square root of x, then that would be a function, right? If we did it in reverse, if we were doing a composition, we would take this here and say, take that, or take this part here and plug it into here. That's what we were just doing on the other part of this lesson. So we're kind of doing the opposite. We're kind of working backwards now here, right? So by doing so there, that'll do it. We've got one of them is that, the other one is this, okay? So you can check your work by doing what we just kind of looked at. So if I plug this one into here, would I get this here? And yes, I would, okay? All right, so the next one, number 4. So this is a polynomial then. So in polynomials, like we said up here, we're going to factor in this one. If we can factor, then it'll help us to get our decomposition. So we want to factor here. All right, so what we'll do here is, I can factor out a 2. And I'll be left with x squared plus 10x plus 25 here. And that happens to be a perfect square trinomial. So I'll have the 2 on the outside, and this kind of is x plus 5 squared. And so now, if I can break those 2 in, if I look at breaking this up and say, well, if I have f of x equals, let's say, again, I'm trying to plug something in, right? So if I just plug this into a function, if I said if f of x was 2x squared, and if I said and g of x is equal to x plus 5, then that would do it, right? If I took this x plus 5 and plugged it in this x here, I would get this action right here. So that's what I want to do, is kind of separate it into that stuff, okay? Oops. Okay, so it should be good. Decomposing these fractions, or these functions, okay? All right, the next one. This is a reciprocal function, right? Because we've got a fraction here, 1 over x plus 7. So again, the reciprocal one, like we said up here, if it's a reciprocal one of these will be the parent function. So one of them is going to be 1 over x, because that's the parent function of this problem. Where'd it go? There's, how did I do that? Clean this up a little bit. There we go. So one of these has to be 1 over x because it's the parent function, okay? So if I say g of x is, the stuff that's happening to x plus 7, right? If I just say that's x plus 7, and then if I say f of x, so one of them has to be the parent function. If I say this is 1 over x, then I will get this whole action right here. Again, just kind of work backwards. You can always check your work. If I said that f of g of x was going to be this here, that would mean I would take this x plus 7 here and plug it into here, and wouldn't I get 1 over x plus 7? So there you go. So there's your 2 functions. Okay, so that's what we're going to do here. Hope that was not too bad for you. And bring some questions for us. All right, we'll see you next time.